You are listening to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the advancing journeyman developer.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
The best thing about a Boolean is even if you're wrong, you're only off by a bit. We've discussed primitive data types in the past. This week, we're going to delve into the world of composite data types. These are types that are composed of one or more primitive or composite types. They may be part of the framework you use and treated similar to primitive types. For each one, we'll give a brief overview of the type and how it can be used. But before we get started, Will, what have you been fighting this week?
Man, I'm doing the end of the year coasting thing.
Nice.
I'm working on getting content done and getting it, getting caught up to where we need to be. My goal is, it's Monday now, is that by the time I leave work on Thursday, to not have anything to do for 12 days.
Nice.
Yeah, because I got like 12 days of nothing. I don't know what I'm going to do. It's going to be wide open, but there won't be any episode outlines needing to be written. There won't be any emails needing to be written. None of that stuff. All done before then. Scheduled a MailChimp. All the crap will be done, and I will find something to do. This will be the longest actual break.
You are going to enjoy this for about the first 8 to 12 hours. Your first day. Second day, you'll get a little bored, so you'll play video games for a few days. After about 3 days of this, you'll be chomping at the bit, and we will have like 7 outlines written at the end of this 12
Entirely possible.
I just know you well enough.
Well, and I don't take a lot of breaks, right?
Yeah.
This is, I think this is the longest break, like vacation type break that I've ever had.
Well, we do have the holidays coming up over this. This is actually the last recording we're doing of the year.
Yeah.
But you're going to have stuff going on with the holidays, but you're also, I know you're going to get bored and you're going to start doing stuff.
Yeah. Because, after I had surgery, I made it. I had surgery on Wednesday, and I told my wife that I thought I could probably go into work the next day, and she's like, "Not if you can't find your car keys." So obviously that was a bust. I really couldn't have gone in the next day. The next day is when it's really started hurting. That said, I had surgery on Wednesday, and I think it was Saturday evening I was starting to get stir crazy, and Sunday I just jumped in and started working on stuff and emailed my boss, and I'm like, "Yeah, dude, I'm working on some stuff, and there's gonna be entries on the timesheet. Sorry, I gotta do something." Couldn't sit around the house anymore. Couldn't really go and watch TV because it hurt.
Yeah,
to sit upright. So yeah, that's totally a part of my character, and that's probably how it's going to play out. But I'm going to try to actually chill out for 12 days. We'll see what happens.
Like I said, you're going to chill out for about 3 to 5 days. I just don't think you can go that long and do nothing.
Yeah.
If you told me, "Hey, I'm going to chill out for about 4 days and do nothing," I'd be like, "All right, yeah, you are. I believe that."
Yeah.
But 12, no. About 4 or 5 days in, you're going to be doing something because you're just going to be going, "All right, I've reorganized my bookshelf. They're alphabetized and in Dewey Decimal, and
No, I won't do that. I might finish the weight room floor, and
yeah, you'll get all the tasks that you can get done, and then you'll go do. You don't sit still. I'm the same way. I couldn't.
I have a hard time watching a movie, legitimately sitting that long. Like when you told me that The Last Jedi was 2.5 hours long, and I'm like, oh.
Yeah.
How about you?
Well, I've been getting level, that is, messing around with getting the first few bytes of a file stream, then returning to the start of the stream. It's I didn't know that the read function in C# moved the position in the stream by the number of bytes that you read. So that caused some really wonky errors. And it wasn't until, because we were trying to upload some files, until we uploaded a text file and we could still open it, that we saw, oh, hey, the first few characters are missing, and it clicked. So I went into the documentation on the input stream, and that's when I figured out what was going on and ended up solving it with one line of code. So I was joking with some of my coworkers that are not programmers. I was like, yeah, I spent half the day on this big problem that we had, because they basically said, and BJ worked his magic and fixed it. And I'm like, yeah, I spent half the day to write one line of code.
Yeah.
The other programmers are like, yeah, that happens. But also, I am without a couch right now. My dad got a new couch for Christmas and was going to give me his couch. So we took mine to storage, and then we brought his down. He lives about an hour away. After 45 minutes, we gave up on trying to get it into my apartment. You know how when you walk in, you got that coat closet right there?
Yeah.
Like the worst possible design for an apartment that people move in and out of a lot, with no other entry into it. So you have to come in that door and you have to immediately turn. We couldn't get the couch in. So he took it back. I didn't go get the other one out of storage. I've got a recliner and that other big chair I had now. So it's actually a little bit more open in there, and you're about the only person that comes over. Occasionally I have like one or two other people come over. So it's not like I really needed the couch just for laying down and watching TV. And then I went over to our writing group this weekend. We meet every other week, and it's been a while since I've been because I've been out of town and then I was sick. Speaking of writing, I've got something bookish for IoTs. This week for IoTs, I have a project that's not exactly IoT, but it's kind of interesting. This is a bookcase for the Raspberry Pi. It's basically building a housing for your Raspberry Pi that looks like a book. They built a case, looked like it was out of plywood, and then painted it. I really liked the kind of steampunk feel of the book and how they added some gears and then the Pi logo on the front. Check it out. The project itself is kind of lacking on specific details, but has some great images of the process of building the case. Who's talking to us this week?
Well, we grabbed a iTunes review from Chris Gallup. It says, I've been listening to Complete Developer Podcast weekly for a while now. I look forward to each new episode. These guys are amazing. They always seem to fit tons of valuable content into every episode. Keep up the great work, Will and BJ. Thanks so much, guys.
Well, hey, thanks, Chris. We appreciate the kind words. Send us an email to neckbeards@completedeveloperpodcast.com with your contact information, because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all of our episodes to Twitter, LinkedIn, Google+, and Facebook. We're also on Path and Tumblr, and at some point in the future, we will start posting on Instagram. Also, check us out each week on Facebook Live, Twitter Live, and Periscope. We broadcast every Monday evening right before we record. We talk about what's going on in the tech world and answer some listener questions. You could also join the conversation anytime via Slack by going to slack.completedevelopernetwork.com. Data types are used in programming to categorize data, be they in a strongly typed language like C, C++, Java, in a database using SQL or NoSQL, or even in a loosely typed language like Ruby or JavaScript, in which there are still underlying data types. They differ according to the language or the database being used. They're primarily used for system optimization and error prevention. Generally speaking, a data type is either primitive or composite. A primitive data type can either be a basic type that provides kind of the basic building blocks for a language, or a built-in type that the language treats and supports as a basic type. If you haven't done so, go back and listen to our episode on primitive data types. Composite types are ones that are combinations of primitive types or other composite types. They may or may not be built into the language you are using.
In past episodes, we've delved deep into some of these types. This episode will be an overview of the composite data types, where we'll discuss each one at a high level. We plan to create future episodes on each type where we'll delve much further into the details about them.
So we're going to start off with arrays. And an array is a collection of values with an index or key for each one. Data is stored so that the value can be found quickly from the index, and the indexes are generally positive integers.
Yeah, the big thing here to remember is it typically is zero-based, and the reason for this is it's a distance from a memory pointer.
Right.
The first one is 0 because it's at that point. The next one is this many units of the size of the data type from that point.
Those are the most common arrays you'll find. You can also find some that are 1-based indexing.
Right.
Where the first value is indexed as 1.
Right. And what they do under the hood is they actually subtract 1 to get their jump table. But it's fine. It still makes it simple especially for beginners. Although I think probably starting with a 0-based and just getting used to that is probably safer than getting used to 1-based and then trying to backstep and fix your habits.
Yeah, I think I would have been very confused had I started with a language that was 1-based.
Yeah.
Another is in-based indexing that allows for the base or the first key to be chosen. Some languages even allow for negative indexes.
Right. And again, they're normalizing to 0, but it's basically syntactic sugar under the hood, so you don't have to do it, which is actually kind of nice.
Yeah, it is a really neat thing that something like that does exist. But like Will said, what they're doing is going back to 0 under the hood.
Yeah.
So arrays can be of varying dimensions. So we're going to talk about one-dimensional and multi-dimensional arrays. A one-dimensional array is also known as a linear array, and the values can be found by a single subscript, so array sub 0, sub 1.
Right. However they denote that in the language.
Mm-hmm.
And then you'll get multi-dimensional arrays, and multi-dimensional arrays are similar to matrices in math. The simplest is a 2-dimensional array where the first subscript is the row and the second is the column. You can pretty much go as high as your language will allow with these. Now, there are some limitations with arrays. In most languages, the size of the array is fixed, or you have to reallocate. In fact, you're doing that under the hood anyway when you're adding stuff to it, but some languages make that more obvious than others. And inserting a new element is expensive as you have to kind of make room for it. So if you put an element in the middle, everything after that has to be copied.
Right.
And so that can be a little bit of an expensive operation.
Next, we're going to talk about tuples.
It's not a tuple.
In math, tuples are finite ordered lists, kind of like arrays. An in tuple is a sequence of in elements. So a 1 tuple is 1 element. That doesn't really work. An 8 tuple is a sequence of 8 elements.
Okay. I didn't know that was called a tuple. I've seen that notation plenty of times, which, it makes sense. I just didn't know that they called it that.
Yeah. It could also be denoted as like an octuple.
What, an 8 tuple?
Yeah.
Yeah.
Mathematicians usually write them inside parentheses separated by a comma. So it'd be, like if it was an 8 tuple, 1 through 8, it would be open parentheses, 1, 2, 3, 4, 5, 6, 7, 8, close parentheses.
You sound like you're going to sell Matchbox cars.
Yep.
The term tuple comes from the use of terms like single, double, triple, etc. A tuple can be any size, so the term represents being any of them. Now, the 0 tuple, in other words, a tuple with nothing in it, is a null tuple.
And a single tuple, a 1 tuple, is called a singleton.
Right, and this is not to be confused with the object-oriented pattern known as a singleton.
Right, and then a 2 tuple, one with like open parentheses A, comma B, close parentheses, is an ordered pair. And then a 3 is a triplet, and it just keeps going like that to infinity and beyond, or as high as your language will allow them.
Right. And there usually is some hard limit on that.
Right.
Somewhere. Now, they can represent data in a record. So, for instance, if you don't really, like in C#, you get a tuple back, and it's item 1, item 2, item 3, and those are the properties on it. At least until the more recent versions. And they can be of different types as well. So you could have one that's an int, the next one could be a double, and the next one could be a string, because it'll work. You can use these to represent data in a record when you don't really care about it that much as far as the structure. It's like, hey, I'm just returning a blob of stuff that's ordered from this method, and I don't want to create a brand new type for it.
They can also be used to provide an output of a method or easy input without having to have multiple parameters to pass in. So we've talked about that in, I think it was our Code Smells episode, where having too many parameters.
Yes. Or too many out parameters. Actually having out parameters, that are that kick back out of a method, that's usually done better in a tuple. And there's actually some threading stuff that goes on in .NET that up until recently, I think they may have actually fixed it, where if you had an out parameter, you couldn't use async.
They have changed that.
Yeah. Well, we're not on that at work yet. So
as opposed to arrays, you can return data of different types. And we've kind of mentioned that already, but within the same tuple, such as you can have a string, an integer, a decimal, so forth, all within the same tuple. So the example I have is tuple the dude equals Jeffrey Lebowski 48 212.5.
Right.
And that is tuple with the string name, integer age, and double bowling average.
Yep.
Which honestly, guys, come on, the dude probably has a better bowling average than that. But,
Tuples in many languages are immutable. So once it's created in memory, it can't change. So you use these a lot for functional programming. I want to say that the C# ones are mutable, but it may be a thing where it's different under the hood.
So they're used rather heavily in lower level languages, and especially in data science languages like Python. Like, try looking up tuples and not getting all Python results.
Yeah.
While they cannot be changed, they can be made to reference other tuples. In languages like Python, you can assign variables to a tuple by placing them to the left. So you could have like open parentheses, birth date, death date, married, children, first name, last name, close parentheses, equals person. And that would pass all of those variables into the person tuple.
Okay.
This basically does the equivalent of several assignment statements. Just some sweet syntactic sugar.
Yeah, and that's actually pretty handy too, because it's really easy if you don't do things this way for stuff to get in between and start screwing stuff up when it's like, hey, I just want to put data here. And that's the only operation I'm doing. So the next composite data type we'll talk about is the linked list. And this is what you typically have running under the hood when you are doing resizable collections. And essentially what a linked list is, it's a collection of values that are not stored in a contiguous location. So you have each item, but along with that item, you have pointers to the item before and the item after.
And so those items are typically called elements or nodes. So we'll use those terms interchangeably as we talk about it. Each element contains the data for that element and pointer information to connect it to the list.
Right. This makes it easier to move stuff around because especially if the element is large, instead of moving, copying that memory and, like bit blitting or something like that, you just say, okay, I'm just going to move this pointer to this other thing.
Right. Yeah. Because the memory is non-contiguous or one right after the other, they can grow or shrink as needed.
Yes. And it's a lot faster because you don't have to allocate a big chunk at once. When you're reallocating arrays and you say, okay, I want to add one item to the end of the array, a lot of times what will happen under the hood is it actually adds 10 or 50, but it keeps track of where the actual end is and there's memory allocated after.
Right. So I have a friend that now works as a front-end developer, but he has a degree in computer science, and we were talking kind of about some low-level stuff and arrays. He was telling me about this one class that he had that was sort of a 2-semester course. So towards the end of the first semester, he was working on his final project for that semester. He described to me basically using arrays because they hadn't learned about linked lists. That was like the first section they were going to learn about the next semester. He created a linked list.
Yeah.
And he turned it in and his professor's like, so you basically created a linked list. And he's like, yeah.
Oh, yeah.
I guess I did.
Well, it is a logical progression, right?
It really is, yeah. There are a few different types of linked lists.
The elements of a singly linked list have a data field and a next field. In other words, it's got your payload or your node, and then it's got a pointer to the next item. That next item does not have a pointer back.
Right. It's unidirectional.
Right.
So it's a single link down the list. Now, a doubly linked list, on the other hand, contains the same thing as a singly linked list, as well as a pointer back to the previous node.
I don't think since we discussed them in school that I've ever actually seen one.
Yeah, so everywhere I looked when creating the outline for this said the only time you'll ever see a singly linked list is in homework, basically.
Yeah, you might have seen it like a really long time ago, but it was before my time that was common.
No.
It's too painful because, what do you do if it is singly linked and you need to put something in there? Now you got to iterate from the beginning.
So the names for these are kind of difficult to say because, well,
singly linked list. Wow,
Peter Piper picked a peck of pickled peppers. Then multiply linked lists has 2 or more fields that link the nodes to other nodes in the list. So it could be doubly linked. A doubly linked list would be a multiply linked list, if that makes sense. But it could also have more than 2. It could be more than just forward and backward. And these are used to connect the same set of data differently. So they may organize data in different ways, such as you may organize an employee by name, by department, and by date of birth. And you have a pointer that goes in the directions for each of those.
Yeah, those things, locations in the memory structure. Typically, when I was in school, they didn't really call that. At that point, they didn't call that a linked list anymore. It was a graph, or it was a tree structure, or it was they had other terms for it. I mean, it's the same concept, but it's just they didn't call it that because
I didn't go into.
Folks are pretty pedantic,
and this is where I shut down the med student.
Yeah,
and I didn't go into that depth. But when we do an episode on linked lists, we will.
Oh, fun times.
Then you've got circularly linked lists. In these, the final node, instead of having a null pointer, points back to the first node in the list.
Yep.
So you could start pretty much anywhere in that list
and iterate through the whole thing back to where you came from. The thing is, I don't know that I've ever seen that used in production either.
I would think you would not need that if you're using a doubly linked list or a tree structure.
It might be a way to implement like a round robin type structure for like load balancing stuff, but I don't think I've ever seen that. It probably happened under the hood, to be honest.
Yeah, and a lot of this stuff are things that you may not see, but may be going on under the hood.
Yeah, and it's stuff you need to be aware of in case something goes sideways. You can think about what data structure they used and probably puzzle out what's going on.
Mm-hmm. So there's one other term that I want to go over, and that is sentinel nodes. These are empty elements that serve as the first node to start a list. This basically ensures that an empty list will have a first and last node.
And that way, if you zero index and get the first one, you don't get a null or get a pointer off to who knows where.
Exactly. So there are 3 ways to insert into a linked list. The first is by replacing the head or the first element of the list.
Yeah, that's pretty straightforward, I think. You just you grab the point, the next pointer off of that, and you put your new item in the data. You can either allocate a new node or overwrite the existing.
Right.
Depending on how you're doing things.
Next, you can insert after a given node. And to do this, you have to change the pointer on the previous element to point to the new one. Then you have to take the new element and point to the next.
Right. And this is a big deal. Like there's a couple of cases here that can come up. One is if the payload is always the same size, you can just replace in place.
Right. Yeah.
If it's not, then you have to create a new node and do that. So some of that goes around your coding assumptions for how you allocate the memory.
So it goes back to like when we were talking about primitive data types. If you have like an integer, that is a set data size.
Right.
So you're going to know how many bits are there. But if you have something like a string, which we're going to talk about in just a little bit, those are of varying sizes.
Right.
And so 2 strings may not be the same size, whereas 2 int32s are always going to be 32 bits.
Right.
Even if they don't use all those 32 bits, they're going to be 32 bits in size. So yeah, that makes a lot of sense.
Half of them don't. I just told a Composite joke. It's all downhill from here.
That was awesome, dude. That was great. Finally, to insert into a linked list, you can add to the end of the list.
Yeah, and that just means you get the last item And where it has a pointer that goes to null or goes back to the beginning, you add a new element and you put the pointer.
Right. I would think this would be the easiest way. Deleting a node from the list is a bit more complicated. First, you have to find the element previous to the one to be deleted. So if you're in, say, a singly linked list, you have to iterate through to find the node you want, and then iterate through to find the one right before the node you want.
Right.
And then store those. And
the metaphor that we were shown in class, which is kind of dumb, but it's appropriate for this time of year anyway, is a string of Christmas lights. Think of the light bulb as being the payload, and there's two wires. Mm-hmm. One's going forward, one's going back. It's not really what, but whatever. How would you splice another one of those in? You're going to have to cut the wires on one side, right? And you're going to have to put the other one in and run wires.
Okay. I follow you. Now, this episode is coming out well after Christmas, but yeah.
Yeah, but we're recording it like literally a week before Christmas. So
literally. It is a exact week from today.
Yeah, so. Literally as in the original meaning of the word. Literally.
So yeah, you first have to find a previous element. Then you have to change a pointer to point to the element after the one being deleted. And finally, you can free up the memory of the element you're deleting. Yes. It's like you don't want to free up that memory until you've done the other steps. That's key. Right.
And the other thing, too, is you want to make absolutely sure that you fix the pointers. Because when you go farting along in that list, and all of a sudden you hit the one that's got a pointer that goes somewhere that it shouldn't, and you get an access violation.
Mm-hmm. There's several other functions you can do with linked lists, and we're not going to go into too much detail, or really any detail, as we'll have a more specific episode coming out sometime in the future about these. But you can find the length of the list. You can also search for a specific element within the list, swap nodes in the list, merge two lists into one, and you can split a list into multiple lists. So linked lists have some advantages over arrays. They're not fixed in size and can grow or shrink as needed.
And because they're not contiguous, it's easy to add or remove elements. Mm-hmm. Because if it was contiguous, consider an array in memory, right? You've got a block of memory allocated, and it's all used up. Next to that, you've got some other crap that you just allocated. What happens when you want to resize the array? Well, you can't resize it into that other space. Well, you can, but you're going to have problems. The only thing you can do is allocate more space to the size that you need and then copy everything over and then delete the old one. And that's computationally intensive.
Mm-hmm. That's going to take a lot of time, a lot of memory, and just not always the best way to do things. Also, dynamic structures such as queues and stacks can be implemented using linked lists. Now, with that said, there are some disadvantages to using them as opposed to arrays.
Yeah, the big ones are that elements have to be accessed sequentially, which slows down your searching. Of course, you can do data structures to overcome this that are like a composite level above, where it's got the linked list so that you can allocate and deallocate, but you also got header information that you write to. So
yeah, I saw some of that.
Like if you want to jump to element 10, you don't have to iterate to 10. It's in the...
Yeah. I saw some of that when I was doing the research for this outline. And I was like, oh, this will be really good. This is when I decided, hey, we're going to have an episode on linked lists because there's a lot of really interesting stuff around them.
Yeah. Another thing that probably isn't going to bother anybody for the most part is that they require extra space in memory for the pointer to the next element. This is not a real big deal with linked lists, but part of the reason you get, like, say, an image file and it's a byte array, the reason is because, hey, it's a big honking file. If you start adding pointers for every piece in there, you're going to add a whole lot of memory utilization.
Right. And what you were saying about not having a lot of impact on people makes sense if you're doing like enterprise level things or writing web applications. Things
right. But
like
if you're
that.
doing stuff on the Raspberry Pi or you're doing something on the Arduino.
That's what I was getting at.
Yeah. It's going to matter a lot. Mm-hmm. And the big scary thing on that is not just the memory utilization, but it's the power utilization. You run a battery down in a hurry if you're inefficient.
Mm-hmm. And also, non-contiguous storage of nodes requires more time to access all of them. Finally, reversing or going backward in a list can be difficult with the singly linked lists. And like we said earlier, you're really not going to see these.
Well, to go backward first, you must go forward.
Exactly. Yeah.
That's it's like the opposite of a time travel movie, really.
Mm-hmm. So for our next data types, strings, I have something that we haven't done in quite a while on the show, and that is I have a quote from someone other than us. This is from Linfo. It's a Linux website. It says, in computer science, a string is any finite sequence of characters. And the reason I quoted that is because I could not think of any other way of saying it.
Yeah.
It's just like...
It's a little more complicated than just an array of characters.
Right. Right. And I liked the way that was said. I'm like, I can't think of a better way or another way of wording that. So I'm just going to quote them as opposed to plagiarizing them.
Which is kind of the same thing. It's just quoting is attributed.
Yeah. So strings are viewed by most languages as a sequence of characters, be it an array or some other type of sequence. Length is probably the most important characteristic of a string.
Depending on how you use it. Yeah, don't ever do it in a switch statement, by the way, without a default. That's dumb.
It tells how many characters are in the string, and an empty string can have a length of 0.
Yeah, that sounds really obvious, but there are situations where you can have an empty string that actually has data in there because it's actually the null terminated type.
Yeah.
And so you just get the null terminus, right?
That makes sense. So I will say this. If you are checking for a null or empty string and you're doing not equals, you need to use and instead of or. So if you're going string not equals null and string not equals empty, then you'll get the result you want.
Right.
I was thinking in terms of, all right, if it's null or if it's empty or if it's this other thing, then it doesn't need to hit here. What I didn't think about was Boolean algebra. When you put the not in front of there, you gotta switch the operator.
Right.
And so I didn't switch those. And so it was, is it not equal to null? Or is it not equal to string.empty? Or is it not equal to no?
Yeah, I've burned myself like that. I mean, Boolean algebra will get you every so often, no matter how much you practice.
So yeah, but I did all that, and I was so proud of myself. I wrote this like super eloquent code. It was really beautiful, and
didn't work.
Didn't work at all. Freaking out. Took me probably about an hour or so to figure out I'm an idiot.
Yep, that's the worst.
So in addition to length, you have substrings, which are contiguous sequences of characters within a string. And we'll talk a little bit more about those in just a minute. Each character within a string is represented by a number, ASCII, Unicode. So for example, in ASCII, if you have the string hello world, the character H is represented by the number 72.
In base 10.
Yeah.
Yeah, typically, like if you're looking at it that low of a level, you're actually going to see it in hex, which will be 48.
Right. That number is then held in the computer as a byte or, a unit of 8 bits, binary or ones and zeros. A lot of times, strings are treated like arrays of characters with an index for each character and an assigned size for that string. So something Will has mentioned in the past is null terminated strings, which are stored with a null character as the final character representing the end of the string. Another way to end a string is byte terminated, which uses a special character such as $sign in assembler or a colon in the CDC system. Bit terminated strings use a word mark to represent the end of the string. So the IBM 1401 used this as its terminal delimiter. ASCII didn't use the high order bit in the 7-bit word.
Okay.
So they use that to signify it. Some languages store the string length in the prefix.
Yeah. And of course, another thing that gets really weird here too, when you get past ASCII and you start getting into Unicode, is the whole code pages thing.
Oh,
where
yeah.
It's not just a single byte. It's some number of bytes that varies per character, kind of what it could be.
Mm-hmm.
And we talked about that at length in the strings episode, and I don't really want to go over that again here because it's painful enough one time around.
Next, we're going to talk about the manipulation of strings, and those can lead to some interesting results. We have a few different ways to manipulate them. First is concatenation, and this is the combination of two or more strings into one. So if you have the string X that is man, the string Y that is bear, and the string Z that is pig, the concatenation of X and Y, so string XY would be man bear, and the concatenation of Y and Z, string YZ would be bear pig. Therefore, the concatenation of X, Y, and Z to make string XYZ would be man bear pig.
I see the South Park reference. And the reason this is important is most of your languages will make this look like the concatenation operator will look like the addition operator.
Right.
But it's not. It's not the same thing. It's overloaded, and it's very trivially provable that it's not the same thing. If you concatenated Z and then Y, it's not going to be equivalent to Y and Z.
Exactly. If you concatenated Z and Y, it would be pig bear.
Right. Which sounds like an insult in a Monty Python movie. You pig bear.
It really does, doesn't it? Yeah.
Yeah.
So
your mother smelt of elderberries, and your father was a pig bear.
Your father smelt of elderberries, and your mother was a hamster.
That's right, yeah.
Your mother was a hamster, and your father smelt of elderberries. So the opposite of concatenation is to split a string or break it into its component strings. Splitting a string breaks it down into multiple smaller strings. So string QR may be split into string Q and string R. Or if you have, string XYZ, that is man, bear, pig, you could split it into string X, man, string Y, bear, string Z, pig.
Yeah, and this is used a lot where you are having to send structured data across a wire somewhere, and you need to parse it back on the other side. You just get basically a chunk of memory, and okay, I can read this into a string. Now what do I do with it? Well, it's got all these different records in there and all these different columns in it. How am I going to break it up? And this is it almost never uses the minus operator to do these things, even though it's the opposite of concatenation, and they overload the addition operator to make it look like addition when you're concatenating.
Right, because, there's not two. You're splitting a string.
Right.
So it wouldn't make sense, because it's not like, I'm going to subtract or I'm going to remove this from the string. It's I'm going to split. And most languages that I've worked with have I'm going to split on this character, or you could split on, if you put nothing in there, then it'll split it into a character array.
Right.
It's kind of interesting. I've had to use this quite a bit, like with what Will said, passing things across the wire. Prefixes and suffixes are parts of strings that are at the beginning or end, respectively. So a string A is a prefix of B if string C exists so that B equals AC. That is really heady for a podcast. So
in other words, if it starts with it, it's a prefix.
So we're going to go back to man, bear, pig. In our string XYZ, string X, man, is a prefix to man, bear, pig.
In other words, it starts with it.
Right. And in that same example, string Z is the suffix. So pig is the suffix of man, bear, pig, or it ends with it.
And the reason we bring this up is because there's a lot of stuff, if you really start digging into comp sci stuff, you'll see that kind of definition for something that's completely obvious, and they'll fill like a page with it.
Oh, I read an entire blog on prefixes and suffixes when writing this.
Yeah, and they can make it completely incomprehensible.
Oh, yeah.
And it's something that your kindergartner learns.
I even have a point in here that starts with, to get pedantic, in order for this to work, both the prefix and the suffix must not be empty.
Wouldn't the definition be that, an empty string is a prefix for every string?
In some places, probably, but somebody doesn't use that somewhere.
Before the word, there was emptiness or something?
I don't know.
There's your religious joke.
There you go. So strings may also be rotated or reversed. So going back to our man, bear, pig.
So you rotate it around a point.
Right.
in the string.
So going back to our man, bear, pig, in string YZ, bear, pig, rotating that to string ZY is pig, bear. See how it comes full circle?
Yeah, literally, because you're talking about rotating.
Exactly.
I don't know that I've ever had to rotate a string like that. Actually, I take that back. If you're dealing with like first name, last name, it's last name, comma, first name. What you might do is
rotate on the comma.
Is do a rotation. But I mean, typically what you're going to do is you're going to be like, okay, I'm going to
split it and then
just do what I need to do with it. Like, I don't know.
Just because the functionality exists doesn't mean you use it every day. Actually, I thought this one was kind of interesting. So
now that gets real weird when you start getting Unicode strings and you have to do that though.
Yeah. So something that I have done is reversing the string.
Oh yeah.
To use the same characters, but in the opposite order. So therefore, string XYZ reversed to ZYX would be gib, riab, nab.
Well, I mean, this is essentially you're starting at the end of the array and just going backward.
Right.
Yeah, I think the main thing you're going to use this for is passing a computer science class.
Yeah.
A low-level comp sci class is probably the last time you're going to use it.
So searching strings typically involves kind of a needle and a haystack approach, like looking for a substring within a larger string. So, for example, looking for the word to in to be or not to be, that is the question. Whether it is nobler in the mind. Okay, I'll stop.
Yeah. And there's a lot of different algorithms for this, and there's also a lot of little complex gotchas. We probably need to talk about regex at some point.
Yeah, that's one of the things on the list to talk about.
But think about the fact that, okay, I've got to deal with casing. Do I want this to be case sensitive or case insensitive when I go through? Do I want to say, okay, I'm looking for the word to with one O or to with two O's? In other words, is there a word boundary on either side?
Yeah.
And that's what regular expressions get into is basically building a little machine that can go through that thing.
Oh yeah, I've had some fun with that stuff, and we'll get more into it in a future episode on regex. So finally, strings are treated differently in various programming language. In some languages, such as C#, Java, Python, at a low level, strings are immutable. Unlike numbers that take a set amount of memory no matter the actual number, strings only take what they need because they could be rather large. And therefore, any manipulation of a string creates a new string because you may or may not have the contiguous memory.
Yeah, and the other thing there too is the issues that come up with multi-threading.
Mm-hmm.
Like you really want, especially like big data structures that you're hitting a lot, you don't want those pieces getting moved around by different threads.
Right. So if the new string is shorter, there's not a problem. But if the new string is longer, you may have overflow errors if the contiguous memory isn't available.
Like if you read off the end.
Right.
I've seen this happen. Actually, this happened to me working with some Delphi code because I forgot to specify whether it was a ANSI string or a Pascal string. And I picked the wrong one. And so what it ended up doing is going, oh, I'm going to read right off the end of this thing. And so it's like, hey, here's the stuff from them. And then there's some garbage. And it's showing up in the UI.
Oh, wow.
And it was obviously pretty quick to detect that. It's like, okay, I know exactly what I did there. But I mean, it's a real problem.
Mm-hmm. In other languages like C++ and Ruby, strings are seen as templates and therefore mutable.
Yeah, and the other thing too is, well, like with C++, they deal with strings at a little bit lower level than we do. Ruby, Ruby's just crazy.
Yep.
They do a lot of things in there under the hood that they made design decisions, and it is the way it is. It's not so much that it's lower level; it's just they're a little bit more flexible about the way they define strings and about the constraints that you put on it. The thing with this is the more constraints you put on, the faster you can go.
Mm-hmm. So next is a topic that we've recently had a lot of conversation about, so we're going to go through relatively quickly, and that is dates and times. These can be dates, date times, timestamps, all sorts of things. It's based on whatever language or system you're using. And a date is exactly what it says it is. It is a date without a time. Date time and a timestamp are used when both date and time are needed. Time spans, something that I was messing around with not too long ago, are measurements of time between 2 points. This is what happens when you, for example, subtract one date time from another.
Yeah, and it gets really interesting though. The definition of a time span. Initially I thought, okay, this is the difference between 2 points in time, but it's not.
No, it's not.
It's the difference between 2 points in time and space.
Yeah,
because of time zones and those kind of things.
Oh yeah, so I've been dealing with some cookie expirations and determining how much time before the cookie expires. So you have to take that in, convert it to UTC, and then compare it to the current date time in UTC, because that cookie is going to get its time in whatever browser it's in.
Right.
So if that browser and the server are in the same time zone and on the same times, then great, no problem. But you go one time zone over, you drive an hour and a half from where we live.
Yeah. Yeah. Or the time zone changes.
Right. So that's something that I've dealt with time span wise. Dates and times are typically represented in the number of milliseconds from an epoch. So the most recent epoch started January 1st, 1970. And some languages can only go back as far as that date.
Yeah. Unless you want to use a custom data type and do a bunch of hacks.
Right. Other languages, however, store the epoch information and can go back even further. In most frameworks and languages, you can get a lot of information from the date time. Obvious things are dates such as year, month, day, time, but less obvious are day of the week or day of the year.
Or what week number it is in the year. There's a lot of those little calculations that get used in finance that you would never think anything about. It's like, okay, is this, what Saturday number is this? Mm-hmm. Or which two Saturday numbers is it between?
Yeah.
Like they actually have to deal with that kind of stuff and come up with functions that can handle that across time zones. And it's ugly.
Oh, yeah. There are several basic functions you can do with dates and times. You can add or remove a time span. So you can add, remove months, hours, days, like whatever. You could compare multiple dates and times to determine what order they occurred in. You can also parse it to a string and add formatting to it. So you could get the month as, instead of 1, 2, 3, January, February, March.
Right. Or get it in, in Spanish, for that matter. There's also the internationalization component that comes in.
Mm-hmm. So for more, including how the computer views dates and times, as well as best practices, check out the episodes that we put out not too long ago in the 3-part series on dates and times. So our final topic that we're going to discuss are records, or structures and classes. These are collections of fields. They can contain all sorts of different data types, usually have a fixed number and sequence.
Yeah, fixed number of fields.
Right, yeah.
And a fixed sequence. Although there are a lot of cases where it's just, it just kind of has the pieces where they are. And so sometimes you'll have to, like in Windows, you'll have to say, hey, for this structure, these fields have to be in this order. Because otherwise, if I pass that over to some external API, it's expecting it can take these chunks in this order. And if they aren't, you will get unbelievably strange things happening sometimes.
Right. The fields within a record may be called members, elements, lots of different things. Basically, they're collections of data types with identifiers for those. Typically, they have kind of a value variable relationship or key value relationship.
Well, JavaScript actually makes this very explicit on the types. It's like, you could say, my object dot whatever equals something, or you could say my object open bracket and pass a string key for that same property name. It's a dictionary under the hood, give or take.
Within these, they specify the data type of the field and the key or identifier. So in a record, you would have like a string name for a person's name, an integer age for the person's age, a date, time, date of birth for the person's birth date. Things like that. Some fields may contain functions or procedures that return the data to that type.
Right.
Now, a structure or a struct is a type that in several languages holds a record.
Yeah, so in OOP, it's called a it's called a PODS.
Plain old data structure?
Yeah. I mean, it's basically just, here is a sequential chunk of state.
Mm-hmm.
And it's laid out the same way in memory. It can't change size. So like you'll see, like in C++, and I think they have this in .NET too, but I haven't had to use it in a good long while. Actually, I know they have it in .NET. It's called the size of operator. So I can say size of whatever this type is. It'll tell me in bytes how big it is, which is why in those you're not going to use a string because you can't, get over that size. Now, what you can do is you can have a pointer in there that goes to a string hanging off the heap somewhere.
Yeah.
And so, that's how you use a structure. Now, with an object, if I remember correctly, and this is pretty rusty knowledge, I think what you end up getting is basically like a structure of pointers to where the actual data lives. Mm-hmm. So it can be, its pointer table is of a given size, but the data hanging off of it is not.
So in object-oriented programming, a class is basically a template for creating an object. It not only contains the data, but also methods of using that data or behavior for it. Constructing a class usually will provide the initial values for state and behavior. Either it will take those in, so with dependency injection, you put those in when you construct it, or it will create those for you. Most languages use the same name for the class and the constructor.
Yeah. Now, there's another thing too. You're talking about structures and classes. We're coming up on a time in C# where we're going to have the classes, as described before, and then we're going to have structures, as we talked about. And then we're also going to have another thing called a record. And what a record is basically, hey, it's a fixed size, but instead of being allocated on the heap, it's allocated on the stack. So you're not putting the memory pressure as much. I believe that's the case anyway. So you'll see those. We have them in Delphi as well.
Yeah.
And it's for really I need to get this done real quick type operations. So it's just something to bear in mind. It also matters where stuff gets allocated and how you lay out the access to those items.
Mm-hmm. So classes can be composed of other classes, creating kind of a compositional relationship. A person class can have a home address of type address class. And within that, it has your address lines, your city, your state, those things. Classes can also inherit from one another. So a car class could inherit from a vehicle class.
Right.
There's a lot more to this, and we're going to get more into it in future episodes. Like I said, this is mostly an overview of these data types. There's a lot of composite data types. You do a Google search, and you'll find too many to even briefly discuss all of them in one episode. We selected a few of the most common of the composite data types. They may be called different things depending on your language or framework, and so we've tried to point that out as much as possible where we knew it. There is a lot to learn when it comes to how information is taken in, passed around, and used in every language. And this has been sort of an overview of some of the ways to do that, and we plan to go into further detail on each one of these and kind of delve into the computer science behind them. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I saw something that was pretty horrible on Facebook. Actually, while we were recording this episode, and we cut this piece out, and I don't know if this story is true or not, but it sounds plausible. And that was that a 15-year-old boy jumped to his death after learning about the results of the net neutrality vote. I just want to point out that, maybe we need to start thinking a little bit more about keeping a bit more of a stoic approach. Convincing people that the world is going to end because of something happening, maybe not the best thing. I mean, obviously, this kid probably had other issues. Nobody's saying that that's not the case. But you never know, when you're going to flip the last switch for somebody. So it's pretty smart to start thinking about, okay, am I really panicking over something that's actually happening right now versus something that I have projected to happen? Because projections can be wrong. The future is a very tricky place. You do not want to borrow trouble out of predictions. Please stop overreacting. This is driving everybody crazy. I get that the net neutrality thing's a big deal. However, we've got to change the tone that we use to talk about this stuff. Because it's not just whether that 15-year-old kid jumped to his death or not. It's bomb threats. It's death threats. It's people just getting in each other's faces and screaming. I mean, can you imagine just how crazy this would look to you if, in some other instance, you had this many people this irate over any other rule that the FCC kicks out? It's ridiculous. So I'm not saying don't be active about it, but try not to get so enraged. Try not to use verbiage that makes it sound like it's much worse than it is. Because there are vulnerable people in our population that may take it a lot further. And, people are going to get hurt. And that's pretty much all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Look for us each week on Facebook Live before we record each episode. Thanks for listening. See you next time.